Hi, hello everyone. First of all, thanks for being here in our Sairam Triple YouTube channel. Let us continue with the previous topic, that is Ohm's law and limitation of Ohm's law. After that, we have a KCL and KVL, right? So Kirchhoff's laws, uh, basically to overcome Ohm's law complications, right? So Kirchhoff's current law KCL statement: algebraic sum of the current, all the current meeting at a junction is equal to zero. Algebraic sum of the current meeting at a junction is equal to zero, or current entering to the junction is equal to leaving from the junction. Just to consider this one is a junction, okay? This is junction, entering current, this one leaving current, right? So entering current is equal to leaving current. This is junction, right? So next we have a continuation. So just to consider this one as a junction, okay? This is a node, okay? And I1, I1, I2 are entering, I3 and I4 are leaving. So at node is a point where two or more elements meet. So node in the sense bus stop, okay? This one Majestic bus stop. So there is no more number of buses are meet together and meet, and then it will come. It will distribute everywhere. So the sum of the incoming current is equal to sum of the outgoing current. Which one is incoming? I1 and I2 is incoming. I3 and I4 are leaving. So next is a Kirchhoff's voltage law continuation. Algebra sum of the voltages around the loop is equal to zero in a closed path. Okay, this is on closed path. Okay, and uh, algebra sum of the voltages and then EMF is equal to zero. So just an example I have given here. There is a I'll just apply KVL over here. So this is I1, I2, I3, I4 will be there. Okay, I2 will be there. This is one branch, this is one branch, this is one branch, this is one branch. So if you write the equation, you will get I1 minus I2 is equal to I1 R1 plus I2 R2 plus I minus I3 R3 minus I4 R4. Okay. Next we have a resistance connected in series. See, number of resistance are connected in series. So R1 plus R2 plus R3, everybody knows. If you want to calculate I is equal to V by R1 plus R2 plus R3. So number of resistance are connected in parallel. See here, three numbers of resistance are connected in parallel. If you want to calculate R equivalent, so 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this type of connection we were referring in the domestic usage, domestic appliances also. So always it is connected in parallel, not series. Okay. So as you can see the diagram for understanding purpose. So just to consider this is a resistance. Okay, these two are resistance. These two are resistance. So there is a battery and then this one is a switch. So this is an internal circuit diagram. Like symbolic representations. So number of resistors are connected in series. So if suppose why I told you, right, why it is connected in parallel, domestic appliances, because if suppose if failure occurs in the one lamp, so the power supply will not be going our own lamp. So that's why they connected in parallel. If suppose failure occurs over here, it will damage, or power will not be flowing but in this lamp, so power will be flowing here to here, so it will not affect to here. So that's why it's a parallel connection. Keep it in your mind. So sometimes they'll ask a Viva question in your home, that is parallel connection or series connection, even though supply from the poles, supply from the transmission lines, so that is parallel, okay, not series. So you can ask me where we are using series connection. So example, so for decorating light, decoration of lightning, LED lighting, what happens if suppose short circuit occurs, automatically it will contact, like a short occurs, so that lamp will be shorted, right? So their decorative lamps, they are using a series connection. Okay, so this is series parallel connection. Just to consider, this is a series parallel circuit. Two resistors are parallel, two resistors are series over here, and there's a 2 voltage sources. This is series parallel connection. Just to connect 1 2 3 4, 1 plus 2 3, and 3 into 4 divided by 3 plus 4, and the voltage you can take 20. So we'll solve some problems. Okay, and finally current, power, energy, and voltage. Current is a flow of electrons with a particular time, with a particular direction, in a particular conductor, right? That's a current. So you should not say like current is a flow of electrons, or movement of charges, or movement of electrons, right? So just to you have to say like this: current is a like flow of electrons, particular direction, particular conductor, and a particular time. I is equal to q by t. Particular charge will be there, particular time will be there, and the voltage. So pressure is required to move the electrons, or potential difference between two ends of the conductor, or I mean, force is required to move the electrons, and power is work done by unit time, and energy is the power into time. See one example, why the power is equal to, I mean, energy is equal to power into time. See, for example, in our home, there is a energy consumption. So usually we all are using energy meters, digital meters or analog meters, but at present we are using digital meters. Keep it in our mind. So digital meter, so it gives, I mean, it records 31 days, I mean 1 month into 24 hours. So 24 is the time, 31 is a energy consumption, I mean like power consumption, power into time, right? So based on that, the BESCOM or MESCOM or government companies, they'll issue a this one bill, right? So that's why energy is equal to power into time. Power is a consumption, T is the time taken, 24 hours into 31 days, right? So this is a relationship of this power, voltage, current, resistance. See here, voltage like this one is a resistance, this one is a current, this one is a power. Just you keep it in your mind. Okay. So once again, power SI unit is watt or joules per second, work done by unit time. So work done is energy. Energy is in joules, right? So current, flow of electrons, electric flow of electron through the electrical conductor. The SI unit measuring electrical current is in the ampere. So one discussion: what is the difference between the BMTC conductor and then the bus conductor? So the difference is same, I guess. Okay, I mean, difference in the sense of similarity will be there. Voltage and electrical potential difference between 2 points. The SI unit of voltage is joules per coulomb. Everybody knows, right? Work done by unit charge is a voltage. That's why work done is in joules, and coulomb is a charge unit. Resistance, opposition of flow of electrons, and opposition of movement of current, I mean movement of electrons. So the ohm is a this one unit.